Alright, you guys, let's go ahead and get started here with lesson 5.8. This is part 2 where we're talking about linear word problems. In this case, students can compare which lines are functions by determining the rate of change. We are going to be focusing on rate of change, which talks about slope. So a few of our vocab terms here is input-output function and rate of change. So let's go ahead and get started here with what is a function. In this case, guys, whenever we're talking about a function, we're talking about one input for every output. So in this case, if we're talking, for example, in linear equations, what they're telling you is that for every x, there's only one y. An example, real life example would be if you pay Netflix, then you get a month free. Or not a month free, but just 1 month, right? Another way we could see this, a function, is once again, there's something going in and then that results in an outcome. So there's an input for every output that goes out. So for example, if you have gas, then you can drive. If you work, then you have money. If you buy movie tickets, then you watch movies, right? And we could go on, right? A few things where something is not considered a function is, for example, if you have an x, one x value, and that same x value has two y values, two different y values. So let's say maybe this is 5. And this y value is a 0, and this one's a 2. So this would not be considered a function because one x has two y values, where instead of one x should only have one. A function of, or a function in real life in this case, guys, is if you pay Netflix, then that means you get a month free, and then you get your homie gets a month free, right? It's not how it's supposed to be, but you know, if you pay it, then you're the only one that should be watching it, but sometimes, you know, it's fine to share. So, let's go ahead and get started here. Starting off here with these points. I want to go ahead and determine whether these points 0, 2, 3, 4, -5, -2, 3, and 7 is a function. Now, in order for us to actually determine if this is a function, we're going to go ahead and actually make a table here. So let's make a table. In this case, and I do have x and then I have y. So starting off with the first one, 0, 2, 0 is x, 2 is the y. Then I had 3, 4. We have x being 3 and y 4. Moving on to the next one, -5 and -2, and then 3 and 7. Now, in this case, guys, once again, we said that for every x, there's only one y. So if you take a look at this here, we actually see that our value of 3 on the x is repeating. So what this is telling me is that the value of 3 has actually two y values. And in this case, I'm going to say that this function here is not a function. Not a function. Because 3 repeats. All right. So once again, that's how we determine if something is a function or not. Whether your x values for every x, there's one y. All right. So let's go ahead and get started with another example here. And in this case, it says, what is the equation to this function table? So they're giving us, in this case, a table of values. And they want us to determine which of these equations is a function of it. Now, in order for you to determine if some points are a function to equations, all we have to do in this case is do basic substitution. And if the statement holds true, then it's a solution. So I am going to get started first with this point 413. And I'm actually going to go ahead and plug it into all of them, just so I could do a process of elimination. So starting off with the first one, I have y in this case equals to 3x plus 1. So wherever I see the y, I'm going to put 13. And wherever I see an x, I'll put 4. So that gives me 13 equal to 3 times 4 is 12. And this is supposed to be a plus sign, plus 1. And then 13 equals 12 plus 1 is 13. So this statement is true for this one. All right, so it works for that one. Let's go ahead and check the next one. I'll do the bottom one. Wherever I see a y, I put 13. And wherever I see an x, I put a 4. So 13 equals 2 times 4 is 8 plus 1. 8 plus 1 in this case is 9. Now, question for you guys, is 13 equal to 9? Is that statement true? In this case, guys, that's actually false. So this is not part of it because you already have one point that doesn't hold the statement true. So next one, y equals a 2x plus 5. Wherever I see a y, I put 13. And wherever I see an x, I put 4. So then 2 times 4 is 8 plus 5. 8 plus 5 in this case is 13. So that one does hold true. Now let's take a look at the last one here. Y equals 3x minus 1. Wherever I see a y, put 13. Wherever I see an x, I put a 4. So that's 13 equal to 12 minus 1. 12 minus 1 in this case is going to give us 11. So that is false. This one doesn't work. So now we're down to just these two. So let's go ahead and try the next point. 2, 7. So in this case, wherever I see a y, I'll put a 7. Wherever I see an x, I'll put a 2. So then this is 7 equal to 3 times 2 plus 1. So that's 7 equal to 3 times 2 is 6 plus 1. 6 plus 1 in this case is a 7, so that one is true. So let's check it on this one. Wherever I see a y, I put a 7. And wherever I see an x, I put a 2. So then 7 equal to 2 times 2 is 4. And 4 plus 5 in this case is 9. So that actually is false. So you see how in this case it did work, the first one, but the second one didn't? Then this one wouldn't be considered a function. So in this case, guys, I'm actually going to go ahead and go with this one as our answer. I could try the other ones just to check, and I'm sure they would work for all of them. So I'm actually just going to stop there. So once again, if you want to go ahead and check if points are part of a function or they belong to a function, we do basic substitution. And if these statements hold true, then in this case, all the points, then it is a solution to it.